My name is Danny. As you know, that's my personality. This is our encrypted chat app. So, as many of you probably already heard, around last year, there was a big scandal with Facebook and Cambridge Analytica. Facebook sold a massive amount of their user data to this company, Cambridge Analytica, and they used that data to create ad campaigns to sway political opinions. And this was a huge controversy, and it really sparked the conversation of people's online security, and it got people thinking about how their online data was being used. And earlier this year, this is a case that's not as popular as the Cambridge Analytica one, but Google Plus had a data breach. Google Plus is, millennials are less familiar with it, but it's it's Google's rendition of a social media. And for the past 3 years, it got revealed that their user data was susceptible to a breach for the past 3 years. So that really furthers the debate of, how much can we trust these tech giants to do right by our data and to really value our online security. And also, now a lot of people feel like this is just a meme, but like people feel that their messages and they're always being watched through technology. And we noticed as a team that there really is this lack of trust online and this lack of trust in online communities. So we wanted to try and use our semester to figure out a possible solution to this problem and create more trust in online. So our solution to this is to create an Android messaging app. This makes Mark Zuckerberg very nervous. And we wanted to make an app that gives people total control of their data. That way they can be in full confidence and in full trust that no one else is looking at their online data. And when we think of Facebook and Google, they offer a lot of services. So obviously we didn't have the time or the resources to try to create and remake all the services that Facebook offers. And when asking around with our friends and the people at our school, we often heard that the thing they valued the most were their conversations. They valued those being private the most. No one wants their conversations to be seen or to be leaked or released. And so when we decided what problem to solve, we decided we would spend our time making a chat app where people can have full confidence that their conversations are their own and are fully secure. And to do that, we're creating a chat app that uses RSA cryptography to secure their data and give the users full control over who can view it. And to make this a success, we wanted to create an easy and intuitive design to maximize user experience, so it does have that feel of you using Facebook's app. It's just this time you know for a fact you're in control and you're the only one who can use that data. And now to come right into it, we're gonna just show you guys a demo of what we made, and we'll explain all the features through that. So when you click on our chat app, it's that icon here, you are greeted by a very simple page. Those are the list of your conversations, but we'll log out as if we don't have an account. So first time you download the app, this is what you're greeted with. A very simple design that's pretty intuitive and most people would know how to use right away. You enter an email here at test and let's create an account. It's not an account. So when they sign up, this is where they're brought. On this page, we explain to them how they have control of their data. So right away, we can create a trusting bond with the user. and here they can read about RSA encryption and the importance of their private key. So a lot of you guys are already familiar with RSA encryption, but we'll break it down in another slide. But for now, to encrypt and to decrypt your messages, you require a private key. You're the only one who has it, and that's what enables people to control their data. So we explain a bit here how to use it. These two logs is how to encrypt and decrypt your messages. Here you copy the private key, the private key, and then you come to your Notes app, go back, create a new one, paste it. So that's how you ensure that you have your private key forever, and you can encrypt your messages. Now you continue, and now you're brought here. Here's where, similar to how MSN messaging works, you put in a phone number, and in MSN you put in a phone number and you can talk to the person right away, and you can only communicate with people whose phone numbers you have. Here it's a little different. It's an online chat app, and we don't want to show everyone's profile to avoid spam. So we have a unique ID where people can put that in and start a new conversation. So if I come here, the unique ID would be transferred just like someone gives you their phone number or email. You come, you would copy it. You would enter it. And now you could have a conversation. And as seen here, it's encrypted. And we'll come back a bit. There's you, it's encrypted. It's encrypted in our database. No one can see these messages until you come back here and you copy your private key, and then you can decrypt it and view your messages. And that's how you can have a conversation with people. And that's pretty much the whole system of how people can control their data. The decryption only happens on the front end, so it's always encrypted in our database. And here is where they can come, and these are just the features of the app at this point. This is where they can come, see their username. If they click here, they can change their profile picture. They can, if they have lost your private key, what happens if you lost your private key, you can't decrypt the messages that have already been sent to you. It's basically like you start over. We generate a new one for you, and you keep all your contacts, but you can't see the messages that you already sent them, or else that would defeat the purpose of, someone would get access to your app, lose your private key, and just be able to restart as if nothing happened. So that's pretty much the gist of the app. Here, if you come back and I want to encrypt my messages, that is pretty much how that works. If you guys have anything to add. And so how we made it. We used Android Studio as an IDE, and you can build Android apps and others like clips and whatnot, but we as a team were completely new to Android, and this is the official IDE for Android development, and there are a lot of resources to learn how to build Android development using this IDE, so it just made more sense to use it. As a version control system, we use Git. Once again, it's the most popular version control system, so there are a lot of resources for us to learn how to use it. And furthermore, it's built-in support in Android. Studio made it really easy to use. And we use Google's Firebase as a real-time non-SQL database. And that's how we store our user data. We do our authentication on that. Firebase has built-in methods to authenticate and store user emails and passwords. And obviously, Android development is built in Java. So how the Firebase database is designed. we split it up into two, into the users on the app and the messages that are sent on the app. So here a user is given an ID. This is the same unique ID that you share with your friends to start a conversation. You have pretty much, if I look at the users, you have a list of the contacts. So these are all the people that, this is a list, usually there would be a couple more. This user has one for simplicity, but you have a list of the contact ID, the last message that was sent to them, and the timestamp of that message, so we can order the messages in chronological order. You have the information necessary for your encryption and decryption. You have your profile picture, the name, and the user ID. And then that's the messages. So essentially, when a user clicks on their conversation, we take this ID, so their contact that they have a conversation with, we find it in our messages, we find that exact conversation, and then we read the messages. And pretty much in terms of how it looks in Java, it's quite simple. We have a people class and a message class, and these fields match exactly our database, the fields in our database. And Firebase has a recycler view that pretty much just takes these fields and merges it with the database and shows the list and goes through every node. Same thing for messages. And now,
so as Daniel explained earlier, we use RSA encryption to encrypt our messages. Although we're not supposed to use RSA to encrypt messages themselves, rather we, in real world applications, we usually use RSA to encrypt the private key that people use for symmetric encryption. But the problem was that we didn't know other encryption algorithms in order to encrypt the messages. The only one that we learned was RSA during our discrete math class. Therefore, we use that this protocol to encrypt our messages. So as we learned in class how RSA works, is that you have a message, we call it M, and then the public key is composed of two numbers, the exponent and the modulo. The modulo is made up of two prime numbers, which you just multiply together. We usually call them P and Q. That's why here we have P and Q. And when we take our message, we raise it to an exponent E, and then through modulo PQ, we get our encrypted message. But to get our message back, all we do is take our encrypted message and raise it to the power of the private key. So it's a very simple algorithm. But the biggest challenge was finding the inverse, because as we learned in class, to find the inverse, we have to use the extended Euclidean algorithm. But the problem is that we had to do back substitution, and computers can't do algebra, so we had to find an algorithm ourselves to do it. And we used Bezout's theorems to find the inverse, of course, as we learned, because we know that the GCD of two numbers, A and B, is going to be equal. We're going to be able to find a linear combination of the two as say plus TV. So we see a GCD of A and B. We get a coefficient of A and a coefficient of B. But when we do the modulo, all we're left here is this part, modulo B, because this is gone. So this stays, and we get 1. So we effectively S is the inverse of A, modulo B. So to find the inverse, I chose an example in the book. So here we do the Euclidean algorithm, and then we do back substitution in order to find the inverse. So for example here, this would be the inverse of 101. So it would be 1601. And then what we'd have to do is, using the extended Euclidean algorithm, we'd have to take these numbers and substitute them back here. But instead of doing that, we're counting the numbers of time that 101 occurs, and 45 times. And then here we get 101 back, and then we get more numbers which we can just plug it back here and count the coefficients that we're adding here instead of doing the back substitution. So here's the algorithm. So if we go back, so here's the mod and div. This is just here, we got the div, and here's the mod. And then we use these numbers and we just add them together, and then we get our inverse back. So this is the RSA encryptor UML. So here we get two static variables, private key and correct key, which is a Boolean. The private key, we use it as a temporary variable to store a private key so that the user, when they read their messages, it uses the private key here, in order to decrypt the messages. Since it's static, we can access it in any method. At first, we wanted to use a shared preference, which is permanent storage. But the problem is that we wanted the app to be more secure. And if someone left the app and came back, the private key would still be there. Therefore, we chose to store it in memory. That way, it'd be temporary. And as soon as you close the app, the private key is gone. And so here are the methods. So we have a method to generate the public key, to generate the private key, to generate times that we use for the modulo. And here we encrypt, we can decrypt, and then here we can get the inverse. Here is the algorithm that I showed earlier.
So this is the general UML for the entire app. In Android, you have every page of the app is called an activity, and you, in this class called main activity, login activity, and message activity, is where we handle all the events and all the code for that page. So message activity deals with all the actions that we want to happen on the message activity, like the page where we showed earlier where you can write messages. The main activity is the main page of the app where we list all the contacts. You can create new conversations. There's login activity where it is the login page. There's register activity where you create an account. There's the private key activity, and then there's the settings key activity. If we look at the main one here, on create is what just creates the what generates the page, and that's pretty much where we write the bulk of our code for almost all of them. And yeah, that's pretty much how the app works. There's not much inheritance. There's not many super classes and subclasses. It's pretty straightforward in terms of main page handles the main page's activities. When we want to pass data from one page to the next, we used intents, which is the most efficient way to do it in Android. And that's pretty much it for that portion of it.
So this is the settings page as you've already seen. So on the settings page, you can see the profile picture, your name, your ID, and the forgot private key button. So for the profile picture, when you click on the picture, it brings you to another page where you can choose an image to upload. And after you choose the image to upload, it stores it in a temporary local file that gets uploaded to the database. And it also adds a link to the image. And on the contacts list, you can see the profile pictures of other people, and it's it's linked to the database, so that when the profile picture link changes, it also changes the profile pictures on the contacts list. And for the forgot private key button, as mentioned before, when you click on it, it deletes all the messages, and it regenerates the new private key and public key and everything else needed for the RSA encryption. And so there's the UML. So there's the database reference. There's the temporary local file. The other reference, the other database reference, and the user ID. So the onCreate method, it creates the settings page and adds a listener to the profile picture, which when you click on it, so as mentioned before, brings you to another page that lets you choose an image. And the get URI method,
that's how we access the ID. We just chose this page as an example for you guys to view how when you, just to give them, because this page is a relatively simple page, and when you press forgot private ID, that's, you click the button and we handle that action in onCreate. So it's just like one of the most simplest pages for those who don't program in Android. That's pretty much where you would handle the action that happens in this page. And that's pretty much it for the explanation of things. In terms of why you would use our app, as you guys seen, it's the user who has total control of their data, and it's that control that enables them to trust our app and trust that they're completely secure and that their messages won't be leaked or used for morally questionable things. So that's pretty much it. That's what we aim to accomplish, and that's what we think the app does. And, yeah.
Question? No question? Okay. Yes.
So like, how did the encryption take place? Like you copy it and then just click the message?
You have your private key.
With the lock icon.
Yeah. So like the lock icon that I clicked on
You can show me.
Yeah. Good.
So you can see here the lock icon. So what you do is, since we stored it in the notepad, we can go to the notepad and we copy it. And when we press on the lock icon, it reads from the clipboard and then checks if the private key is right. And also it erases the private key from your clipboard. That way, like in case you forget to wipe your clipboard, someone can't use the private key that's already on your clipboard to decrypt the key again. So all you do is copy it, press on the lock icon, and then you got your messages decrypted. And then you press it again to encrypt your messages.
Any other question? Okay, thank you.
All right, hello everyone. We're going to be presenting our app called WIP, which we call a weather inclusive navigation app. So the goal of the app was basically, like we said earlier this semester, to combine weather and navigation in a easy to use way, so that you wouldn't have to rely on two separate apps for your long road trips. So that was the whole idea of the app. And yeah, so we have a little demo of the Alright, so basically this. So this is what you get when you first open the app. You've got a menu here with two quick settings, but basically the way it works is pretty simple. You just input an address, whatever this is set in Philadelphia, and you get here the location. You can click on directions right there to. Nope, my bad. Oh, Wi-Fi was off. So yeah, that's actually one of the features we implemented, is that if the Wi-Fi is off, instead of crashing, it would prompt you to enable it. So now that it's enabled, we can get the directions, hopefully. Yeah, so you get a direction from your location to where you want to go. And then if you press the arrow on the top right, what you get is first is the forecast for different look. So you get a forecast for different locations at different time intervals, and if you click on the top left for weather, you can switch for directions. So and the button here refreshes the weather forecast so that you get the most updated data. Should I just show all the features? Alright, so we also got a night mode, which I will explain later, but basically you had to force the app to reset in order for the map to change. So we got a prompt for just asking the user if he's fine with it, and when you press OK, it comes back with in dark mode, and you can disable to go back to normal mode. We also got the toggle units to change the units from degrees Celsius to Fahrenheit. So let's say you get here a list of weather. You see it's in Celsius. Well, if you click on toggle units, you will get them in, and if you refresh, you will get them in Fahrenheit. That's basically it for most features. So yeah.
We'll go more in detail in each further in the presentation.
How do you go to the screen? So basically my roles were mainly UI based, so I was in charge of designing and implementing the left drawer menu that you saw, also to get the slide menu to open properly and close properly to display the directions and weather, and also the night mode, which happened to be a lot harder than I thought it would. So the tool and library I personally used were the slide up, because I initially did a manual slider panel, which it worked, but it was very glitchy and wouldn't, and sometimes it would display over things even though it wasn't supposed to be there. And some glitch, so I just ended up using a custom library, which made it a lot easier and cleaner. And Recycle View is basically what the three of us use to display the information in the little as sort of items that you could put inside the slider panel, which would display all the weather forecasts and directions. So of course I had a lot of obstacles, but some of them, one of the most important one is the night mode, which I thought would be a simple line of code to change the color of the map, but turns out it's not that simple, because you cannot, like I said, change the style of the map without restarting the app. So I had to learn a thing called shared preferences to save an integer value that would stay saved even though the app is closed or is reset, so that the map would then, when it's initiated, would see what the in value of this is, and depending on whether it's 0 or 1 below the different type of style. And also initially we wanted the slider menu to be slidable, but it was interfering with the whole dragging the map around, and we thought, so as a solution, to just have a manual button to open it. Yeah, that's basically what I explained for the night mode. So this is how I thought it would be, but then there's a bunch of other code with shared preferences, so that it saves the input and then it keeps it until it's changed again. And yeah, so this is just to show that basically we implemented a button instead of the slider.
So my role constituted basically of replicating the navigation, the map you see, say, on Google Maps. It looks a lot, well, our app looks a lot like Google Maps. That was the point. So if we go through each step, I started by first getting a location and internet permissions. Our app does use location and internet. And then I implemented the search bar on top with an autocomplete engine. Then I did the get current location button. This part of the code will be reused afterwards to get the directions also. Then you could also drop a marker if you long press on the map to get to set a destination. Then I added with the get directions button, basically you get all the possible routes doing an API call and then parsing the data, the JSON file that you get back from the directions API. And then there's also a start navigation button, which we didn't show in the demo, but essentially it just changes the angle, the tilt, the view of the map so that you can start driving and following the path that you chose. And finally, the navigation drawer with all the instructions, turn right, turn left, go straight, etc. In terms of map UI, for the search bar, I have to do with the box and all the info boxes at the bottom. Also laying out the drawer with the icon, the instruction, and then the time and distance of each step of the way. And finally, the toggle units feature I implemented at the end, which switches from Celsius to Fahrenheit and back and forward, and also from meters, kilometers to feet and miles. So tools and libraries I used, first of all, a lot of Google services and the directions API. They're right there, I won't go through them. And finally, there's Firebase at the bottom. We didn't, since we didn't implement any user, this is for future use if we decide to do more with this app, but it's just there in case. And finally, for the autocomplete engine, it's I found it on GitHub, CPeak, and yeah. So obstacles I came through. Going through making the map was a learning curve, but got through it pretty relatively quick. But then the challenge was in synchronizing the API response and the parsing with displaying the information on the map. Doing an API call through the internet, it requires time, and so I had to synchronize that, and then following, once you get the response, the parsing, and then once all that's done, I could only display the info on the map to avoid errors. And another obstacle would be, in order to enable Nepheus to do the weather implementation, I had to select points along the route to send to him, but not only that, but get the time it takes to get to each point. And so a workaround for both of these obstacles, the first was using async task class. This class has two methods, do in background and on post execute. The do in background method, well, here's an example of basically the API call. The download URL method does the API call, but it does this in background. Once all this is done, it only goes in post execute. And the parsing method is executed, and then the parsing method also is an async task class. And once the parsing is done, only then I do the information on the map. And now for the 10 points, the points I wanted to give to get the weather, the directions API has a feature with waypoints. So what I did is going through the initial API response, there's a polyline which has a set of lat longs. Basically, I picked 10 points at 10 at equal intervals. And those 10 points I used as waypoints within a second API call. And so this enables me to, well, with this I could get the time and distance it takes to get to each of these points, which I then stored into a list, a rather complex array list actually, which saves the lat long of each of these points, the duration and the distance it takes to get to them. So highlights of my code was a 4-step navigation. First, you could search your destination with an autocomplete engine or drop a pin, but then you're prompted with the destination page with the address at the bottom, and you can choose to get the directions. Once you get the directions, you get to choose a route. One of the features that wasn't mentioned before is that you have a choice between multiple routes. This one here, in this case, you have 3, and you could pick and choose between them, and all the information related to it changes also. And then once you're done, you chose your route. You can press start. The view changes, and then you're ready to go. You could obviously exit this mode, and always you're able to center your view on your current location. More highlights. This page, it's the instructions directly from the directions API response. So it's fairly self-explanatory. You have the instruction itself, the time and the distance of each of these steps, and then a little icon on the side for visual reference. and more highlights. You have the toggle units. Basically, this is the same route with both units displayed. Things I would have liked to do, or things I might do in the future that I regret not doing, maybe would be to have the Directions API lets you have multiple modes of transportation. So ours is default by car, but maybe implementing a way of doing public transit, walking, and bike also. I would add adding waypoints, say like in Google Maps, when you set a destination, you could also add different points you might want to stop by. Say I want to go to Quebec City, but I want to pass by a supermarket on my way there. I could add that. Place information. Yeah, when you choose your destination in the search engine, in the autocomplete engine, it's not. They come up based on not on relevance, popularity, proximity. It only comes up by how it matches the text you wrote. So maybe find another search engine or make one myself that takes proximity and popularity into account. And finally, the navigation mode right now is early stage. It's only a view. Maybe have instructions at the top, alerts from weather, make it more user-friendly. That's for me.
So my name is Nafis, and my main role is related to transforming raw information into classes. So what that basically means is that if there are important data that Felix and Chris are working with, and they're not in the ideal format for using in another code, I'll create a class for that so that it becomes easy in the long run. I also work with the weather in general, so I'm responsible for communicating with the darksky.net and to retrieve weather forecasts from that. And I also ensure that the weather is updated properly, so when and how it should update. I also ensure that the weather information show up properly. I don't work with the UI directly, but I make sure that the text and the numbers appear properly. I also resolve problems and try to understand problems related to GitHub, because it just so happens that I know the most about it. And also try to understand the Android development tools. So, for example, the team had issue dealing with Recycler View, and with some documentation reading and some testing, I learned that you can update Recycler View by having its adapter and then calling notify data change. I also learned that it changes its elements by first checking what is the size count, and then it updates the items using on-bind view holder. So the libraries I used, or tools or APIs, is Volley. Volley makes requesting HTTP requests easy. I also did some unit testing at certain points with Mockito and True to test my algorithms, but because we developed pretty quickly, we cannot catch up with my testing code cannot catch up with the current state. And finally, I used darksky.net. So the main highlights of my development is I created an almost reliable weather system. So here, for example, is I looked for the directions between Montreal and Toronto, and I started the search at 4:50 p.m. So here, in 30 minutes inside Montreal, it should be 17 degrees Celsius overcast. And in this weather from the weathernetwork.com, it is 16 degrees at 5 p.m. and 16 degrees and 15 degrees at 6 p.m. So here we can see it's like 1 or 2 degrees off here. And overcast basically means it's cloudy. Well, here it says mainly sunny, but it's almost reliable. And here Toronto, so the trip takes 5 hours and 27 minutes. And that will be between 10 p.m. and 11 p.m. So according to this dark sky, it is 17 degrees Celsius after 5 hours and 27. And here it is 6 degrees Celsius, which is 1 degree off. And according to this, at 10 p.m. it's cloudy and 11 p.m. it's light rain. And while in the dark sky, it's breezy overcast around those times. So it is fairly accurate because here it's cloudy and here it's light rain. I also ensured that the app did not crash by forcing users to enable Wi-Fi and GPS. And I also made sure that if the user asks for directions and for some reason the user decides to interrupt the Wi-Fi in the middle, I made sure that it doesn't crash by forcing them to enable Wi-Fi. And this one is one of the most important contribution because when I first started developing this, I noticed that when I tried to retrieve my location, it took a really long time, like 1 hour or something. And I tried to do some research because Google Maps works really fast, but this app works pretty slowly. But then what I noticed is that the reason why they were able to get their location fast is because they had our Android apps has Android has like 3 options for the GPS, like low priority, medium priority, I think it's called, and then high priority. So the low priority only uses GPS, while the high priority uses both Wi-Fi and GPS together to get your location. So I did some research and I found something called Location Manager, and essentially this lets me retrieve my location using GPS only. It still takes a few minutes or seconds, but it was a lot faster. So now developing and testing my code got easier because of this. And my regrets throughout this development is I did too much prediction with what code I should write. That mainly because we were pretty early, we didn't know how to plan. So for example, I wrote a class that will calculate the distance and then get the time to run it, but then I learned that Chris is already doing this. And also, I also tolerated miscommunication at a certain point in the beginning, mainly because the class tends to be loud. So I'm not certain. Sometimes I'm not sure what he wants exactly, and that also made me lose some time. And I also regret not. No, I meant to say fix my team's code as soon as possible. And that doesn't mean that my code is better or their code is better. It's just that I feel there are certain ways that the code could have been optimized early so that in the long run it's easier to work with. So for example, instead of using maybe a list inside a list, you could have a class that will make it more abstract. And what we hope to do with our app is to, everything that Chris says, including add the ability to see more weather. So weather information like wind speed, wind direction, add the ability to see forecast of each point. So yeah, basically like if you, for example, click item in the recycler view, see more weather ahead of time so that you can make decisions based on that. We also hope to add alert system and maybe make it a widget for Google Maps because we don't want to compete with Google, we want to make Google Maps better. And if we have more funds, we hope to include weather for more points because right now we are limited to only 10 points because if we make a request for like 100 points, we will use up 1/10 of our dark sky requests. And of course, we hope to publish our app to Google Play Store.
So with all that said, for those who wonder what WIP stands for, initially we said it was weather and trip width, but after we did everything, we do have a final product, but we could also say it's a work in progress.
Any question? No? Okay, thank you.
Good morning, everybody. I'm Samuel.
And I'm Andreas.
Today we're presenting our Java project we did for the semester, an archery simulator based in JavaFX. What we had initially planned was, well, we're going to start with the story, and then we'll go on to the physics, the saving and loading system we developed for this game. We're going to be talking about the design for our project. We're going to be talking about the goals we wanted to reach. We'll be quickly touching upon our UML. We'll talk about how to play our game, and we'll conclude and let the other team go. So the base idea for the game is we really wanted to do a game based off of science, because at least how I understood the course goal was to do something related to physics or chemistry. And we had initially thought of doing something chemistry based, a sort of quiz game to help chemistry students help with studying, but we figured that wouldn't work, so we decided to do something physics related. We also decided to do something that would relate to the old Flash games back of the mid-2000s that I'm sure a lot of people here have played and enjoyed. With that in mind, we set on to an archery project, since it would let us examine mechanics, ballistics, physics, gravity, all those nice things we saw and suffered through in physics.
So for the physics engine, we ended up using a library because doing collisions on our own would take forever and it wouldn't be nearly as good. We have a few types of objects. We have our arrow object and classes, our bows that shoot the arrows. We have our obstacles, and we have our items, which are power-ups, and we have our targets also, which are the goals when we want to complete the level. We have our physics concepts. Everything comes from the collision library, such as the gravity, the collisions within the items. We have some special physics interactions, such as you can set an arrow on fire, and we can destroy wooden objects, such as crates. And those are like special collision handlers. We have to go into the collision library and like put that in. And yeah, that's about it.
So for the saving and the loading feature, we decided to use a database. So in the database, the player will enter his username, and which will also act as a password. And in the database, he will also have the levels he completed and the score of each level. So when you start a game, you enter 3 letters, and the game will give you randomly 3 digits, and that will be your access code. And when you want to continue the game, you just enter your code, and then the program will extract from the database the last level you played, and you can continue from that point. And so for the design, for the menu, we used Paint. But for the level we switch, we use Paint.net, and all the objects, the bows, the arrows, the items, the obstacles, we did them in JavaFX.
The goals of our game were twofold. First, as we still wanted to have the science aspect in it, of course, is to learn a bit, have a bit of fun using physics, mechanics, parabola, gravities, all those things we learn, as well as have a bit of strategic thinking. One of the aspects of the game is that in each level, you don't have unlimited ammo, you don't have unlimited arrows, you really need to think about each shot you take and figure out the best angles. We also wanted to have something of a competitive aspect, since that always seems to get people motivated if we look at stuff such as Kahoot. So with that, we created something of a leaderboard and score system. Depending on how fast you complete the levels, you will get a certain score. At the end, you put all your scores together, and the top 5 will have their scores on a leaderboard. Anyone who plays anywhere can access these scores due to the database that we have that we're using.
We'll quickly go through how our program is structured. So our first package is our final menus, all the classes that have to do with the menu, such as the leaderboard, the continue. Then that takes you to the level package, where you have your level, and also your level data, which is how we store the level in a separate file that goes from it and puts it into level. The level starts off with a bow, and our package archery.bow has arrows, bows, multiple different types of arrows that extend the arrow class, different types of bows that extend the bow class.
And then we also have our item and obstacles, which both extend our physics interface phys-obj, which has to do with both Java effects and our collision library. Just puts them together, so they're packaged together in the graphics. And then we have all our different items and all our different obstacles.
So the game is pretty simple. You have a bow, and you can adjust its angle, and you can draw, so to shoot the arrow. However, as Sam said, the number of arrows is limited, but there are certain items in the level that can increase the number of arrows. Besides, you also have different items that can change the type of the arrows, or that allows you to fire multiple arrows at a time. And also you have multiple obstacles, but these obstacles can be used to your own advantage if you know how to use them.
In conclusion, really, it was something of a tribute to old Flash games, old arcade games. Things, say, the old Pac-Man games, for example, where you'd enter a 3-digit username to be shown on the leaderboard, or the old Buddy game, for example, that's just something you load up on your computer when you're bored, play for a few minutes, have a good time. All those types of games. You wanted to learn a bit more about dynamics, physics, mechanics, gravity, collisions, transmission of force, get to see that in action more so. We wanted it all to be an interesting and amusing package, something you open on a lazy afternoon, have some fun with, challenge your friends maybe to see who can get the highest score, who can beat the level the fastest. We wanted to be competitive as well, as I just said, that's why we have the leaderboard. And we wanted a bit of resource management as well. So that's what our game is all about, really.
So now we will show you a demo of the game.
We're not going to show every level, we don't really have the time, but we can go through most of them or a few of them. So this is our menu. You can either, when you create your user, you can go to new game. There you can put the username you want, so like, I don't know, ABC. And then you get 3 random numbers. So ABC583 in this case would be your username. And then you can start playing. 583. We're not going to use that. Yeah. We're going to use like something that already has everything unlocked just to make sure everything. So after you beat everything, you have all access to all the levels, but when you play through them, like after you beat level 1, you have access to level 2. We're going to show off starting with level 2. So we have our game, we have your vote. We have a split shot power up. When you shoot it, your next shot has 3 arrows, and then you like shoot 3 arrows, and so on. When you hit the target, the game ends, and you get back to the menu. This is Cosmo. This is our Cosmo, it's another type of boat. This one has always the same force when you shoot.
The fact that it always has the same draw distance means you really need to think about the angle, basically limiting what you have to accomplish a certain goal.
Here we're showing off the switches. They can be turned on, off, back on again. We have a crate and a torch. When you shoot through the torch, here I missed it, so nothing happens. But if I shoot through it, the arrow becomes a fire arrow, and the crate disappears. And I'll show this one last. We have a switch, a power up that transfers your arrows into heavy arrows, and then these can be used to like move the blocks onto the pressure plate, and then you can just shoot the target. Can you show more levels?
My signal showed enough. We had to keep some surprise after all.
Nope.
We decided to not really care too much when we made the usernames.
Yeah, so this,
Right. Hi everyone. I'm Charles. I was working on our final project with Thierry and Matthew, and fortunately we did a Minecraft mod. Okay. Does anybody not know what Minecraft is? Okay, Guillaume. Minecraft is a very popular sandbox game which you load into a world of blocks, and you can basically do whatever you want depending on the mode you are playing. So either survival, which you have to survive against monsters and build your house to kill the Ender Dragon, or creative, where you can build whatever you want with infinite resources. So with the final project objective was to use science elements into our mod. We chose chemistry, so we did a chemistry minigame into Minecraft, which consisted into a single-player game, which you have to complete chemistry-related objectives and complete them before a bot does. All right, so why we think our project is very epic. First of all, it is pretty fun and gameplay-oriented. It is very popular among children, so it introduces them to basic chemistry elements. That was our main objective into doing this mod. It was very challenging to code because we had to adapt to someone else's code and 3D textures and maybe code that was a little more advanced that we learned here. And it's good looking as well, so it's cool. We use many tools to develop our mod. First one is GitLab. Everybody used that, so yeah. Eclipse, which is the IDE we used with Java language because it is the closest to what the developers of Minecraft use. We used Photoshop to create new textures and models for our new items. We use an app that is called Mr. Crayfish Model Creator that allowed us to create new blocks and their models and just puts every file the game needs to load these models. And finally, we used Forge, which allowed us to access the Minecraft game code and to create our mod. So, without further ado, let's play.
yes.
So basically, we're going to explain to you all the characteristics of our mods while Charles is playing the game. So because we found it easier than to just put pictures on it. So the first characteristic we implemented is when you load the single player, you'll see that we have a create from template. This is a mod that already existed that we took. So you don't need to go put back the elements in the chest. You'll understand a bit later why we say that. But you never need to go put back the elements. Every time this is the new map. So you'll get all the elements in all chests every time you load the game. So now we create our new world and we start the map.
So we're going to be spawned in the lobby.
Yeah.
We're going to show. So now that we're spawned in the lobby, we're going to show a bit what are the different functionalities we implemented into the mod. So starting out, we have this first chest. And we have a book that we wrote handwritten, and it's basically a 6-page thing that introduces the user to our mod. So are we reading through it?
No. And also, when you spawn, I don't know if you've seen, but you get a message that says to the player, open the book right here, open book in chest to have info on how to play the game. So every time you spawn, whether you quit, you come back, you'll spawn in the lobby at the exact same place with this message. And why we did not make save games is because the game lasts I think that it's like 10 minutes maximum. If you go over 10 minutes, the bots win the game. So that's why we just implemented that message, and every time you go back to the lobby.
So now we created a separated tab. To be able to access our items, because you know how Minecraft has separate tabs for all the separate things like miscellaneous items, etc. We created one that was precisely for our chemistry mod, so that we could put all the items that we needed, and we could keep them all in a nice little package that also looks nice on presentation. As you can see, we put Champlain's beautiful face as the icon, and we have all of our items. So As you can see, we have the weak acid and the strong acid, a weak base and a strong base, some salt, helium and hydrogen, a cheat, which is Poulen's face. We have a chlorine, calcium, and sodium elements plus copper. We have the molten elements, so molten copper, platinum, and it's molten. We have the lab goggles and a lab coat, which are very fancy. We have the molten emerald, molten salty water, molten gold, molten diamond, and an alloy.
Right. And another thing that is not in the chemistry tab, since it's the potion tab, but we implemented 3 new, brand new potions. So the first one is a fire potion. Just be sure to take not fire resistance. The other one, this one. Yep. So the first one is fire potion. We have then anti-gravity potion. All these are in the potion tabs. That's just why it's anti-gravity potion. And finally the faster potion. Faster potion, it was already implemented in the game. It was more for us to like learn how to make those potions. You go still way faster than a faster potion in the game. So we're gonna present to you the 2 main armor we made, so the lab coat and the lab goggles. As you can see, you wear them on you, so we have the goggles over here and the lab coat. And the lab coat, what is very fun with it is that when you drink the fire potion, you don't get any damages of it. Yeah, but again. So when you're in survival and you drink the fire potion, you don't get any damages out of it, but if you remove the lab coat, you start getting damages. So it's like a protection of when you do dangerous chemistry. Now we're gonna show you the game mode. Well, you can maybe show the anti-gravity potion. And you just get to fly in the air.
The initial goal
and you can't go back at the bottom.
I'd say the initial goal for that thing was that initially we wanted to make the game a multiplayer game. So we wanted to make possible potions that you can turn into splash potions, where you can throw on your enemy. So in the event that you craft an anti-gravity potion, you could throw it at your enemy and have him fly in the air, so that you could complete your objectives while he was hanging there for an extra 20 seconds. It added an extra element of competitive, and if for the fire, and we had more ideas for potions, but we weren't able to make the multiplayer actually successful.
So now we're gonna show you the game mode. So the game mode, we have 2 game mode, one easy mode and one hard mode. The 2 main difference between both. First, the map. The map is a bit different and a bit harder in the hard mode. That's kind of logic. And also the bot is way faster in the hard mode. So when you're in the easy mode, it's like for the kids to have time to go see the chests and everything. And when you're in the hard mode, you really want to compete with the bot. Because as he said, we're now in a single player against a bot, and it's just an automated bot which do that number of objectives every number of seconds. So now if you type in play easy, you're teleported in the easy map where you can see right in front of you, if play just move this a bit, the objective table. This is the main part of the game. Every time you get an objective right, because I don't know if you saw, but in the message box again, you get your objective, so make a weak base. So the goal is to go find a weak base around the map. Every time you make you find your objective, you go put it in the objective table, and the countdown is going to go from 3, 2, 1, check your objective. If it's good, you pass to the next objective, and if it's wrong, you go back you stay at the same objective, and it says that it's a wrong objective, you need to try again. So now we're going to show a bit to you the map and how the game works. This is all a map that we implemented ourselves, but more Charles implemented himself, and he all constructed it by itself. It's not like a generated map or nothing. It's really us that constructed it. So now he goes to one of the part which you need to make a bit of Parker to get to there. This is a block we also implemented. It's just for decoration, but it's an alchemy table which have like a doors and a little it's kind of potion, but I don't remember the name, but that is exactly that is related to alchemy stuff. So if you open the chest, you'll see a ton of potions. As we said with the other mod we implemented, every time you reset the map, this is gonna reset also. So you never need to go back put potions by yourself. So now the objective was make a weak or a strong base. I don't remember. A weak base. So you take a weak base, and then you go back to the objective table. That was sketchy. And as you can see, the bot is gaining level, so we call it Yuri, and he's just gaining level as he plays. So now he's now level 2. So when you put the objective in the objective table, 3, 2, 1, boom, check your objective success. You're now at level 2, and Yuri is one objective ahead because he got level 2 and you are only at level 2. So Yuri is playing currently objective level 3 while you are playing level 2. So now you can do that as much as you want because you can go search every component of the game, and well, there's a ton of objectives. There's like make an alloy, neutralize salt, neutralize to get salty water, stuff like that. Go back to lobby, we'll show recipes. So now we just typed /lobby, which teleports you back to the lobby, stops the game, stops the bot. And we just want to show you some recipes. So with the hot plate, this is a GUI we implemented ourselves. So when you right click on it, it's a new GUI, which it acts a bit like the furnace.
So basically, this was my portion for the project, the hot plate, and getting all the functionalities to work and making sure it doesn't break when you, let's say, add stuff. Let's say when you process stuff and you take out an item, say it like duplicates all the items and it would get lost in your inventory. What we did is basically I adapted it to all these new items that we added, and what you can do is you can put it inside the hot plate and it will process it just like Minecraft does, and it will give you a molten of that item itself. And we had a lot of issues with it. We had a lot of issues with syncing up the tile entities for for the hot plate on the server, and that's one of the main reasons why we weren't able to put it into multiplayer.
So now if you mix the two of them, which is another recipe we implemented, you get an alloy, and that's one of the objectives you need to do. So if you take your alloy, you have your brand new, one of the brand new items we implemented. Also, there's a ton of more recipes. We won't have the time to show all of them, but there's like the cheat objective, which is the face of playing, which makes you advance on one objective anytime you get your objective right. Now the last thing we want to show you is the hard map. So if you go and type in play hard, you get teleported to the hard map, which is still the same game, still the same objectives, but just in a different map and with a faster bot. So the bot is going to be a bit faster. So that's all implemented by ourselves. Again, the alchemy table.
I hope no one's prone to epilepsy when you do that.
If you go where the objective table is, the objective, and again you'll get your success and here's the next objective. So that's basically our game. It's how it works. It's the two main maps. It's really how we wanted to implement it. I don't think there's any more features to show. Maybe just show the cheat. Maybe. So if you take the cheat objective and you put it inside it, you'll just get always the next objective. So if you find the good components and you just make like a ton of cheats, you can cheat and do it, but it's a really hard recipe. I don't even remember it by heart. It's like
it's 4 elements together.
It's 4 elements together in a certain order, so it's a really hard recipe to do, but and you need to find the 4 good elements. But yeah, it could be a way to be sure to win the game.
Then let's say you want to play another game. You go into single player, you can delete your own map because it's been used and some items have disappeared. Create a template, create another map, and then the map is brand new. You spawn into the lobby.
Thank you very much.
Question?
I have a question.
Yeah.
What happens if you die? Does it do you just
yeah, we can
respawn?
show it. We can show it. Actually, you respawn in the lobby and it sends you a message. Well, in this one it's easy.
Yeah.
And you die, be more careful with dangerous stuff. You can try again if you want, just use the preferred counter. So we thought about this, and you just spawn back in the lobby, but you don't spawn in the easy or hard map. It's really like you start over. It's a yeah.
Why don't you like try the previous server?
We tried and like it's not implemented.
It's gonna work, but the player that has joined the host is not gonna see anything. If he puts an objective in the table, it's not gonna do anything.
Yeah, exactly. It's like it's not implemented for us. Really, at the beginning we wanted to do that as Matthew said, but now it's more like
we tried to communicate between the client and the server, and it's really hard to figure it out.
All right, so
Okay.
basically.
Thank you. Start.
Hi, welcome everyone. Today we're obviously going to present you our final project, which is called Project Relocation, and we're going to head straight through it.
Okay, so I'm just going to remind you guys what was our project initially. So we wanted to do a game, a learning game. So the goal was to introduce people to the programming style thinking. So we did a game with a rocket that you have your own command. So you can drag and drop blocks of code, and you, the user, will have to input the acceleration, the wait time, and the rotation. So while having fun, and our story was about spaceman Bob, if you remember, the astronaut that he wanted to go to his homeland, and he wasn't able to land on this platform because he needs to refuel on different planets, and he needs a co-pilot to help him land on his planet.
So for the design aspect, we actually designed every visual aspect ourselves. So we used Google Images, we transformed them into Photoshop. We use different text fonts. So there's the title and the shop font, the actual in-game font that is used widely, and the command blocks that we are used to are all designed ourselves. We use CSS for every button and every string that is visualized in JavaFX. We use CSS. Also, the music, which you are going to hear, is made by ourselves too. I think that's pretty much it for the design.
Okay, so we're going to show you our game and the features now.
We're just going to mute it for this.
Okay, so this is the main menu. So you have the options to create a new game or load a previous game that you created. So we're, yes?
Okay, sorry.
It's okay. So we're going to create a new game. So here you can enter a username.
Anyone want to suggest anything? Okay, we're just going to we're just going to
Okay, and here you have the message that I basically explained to you. So, hi, Bob needs a co-pilot to assist him in piloting the rocket. He is far from his homeland and desperately wants to go back. Unfortunately, Bob's home is so far that he needs to refuel on 6 different planets along the way. So, will you help Bob reach his planet? So, you say yes. If you say no, you're going to the main menu, back to the main menu. So here you have a page of instructions. So here you have a video, you can play it in the background when I'm explaining. So here the basic instructions, is one, drag and drop the blocks desired in the timeline. So here on the left you have the blocks of code that you can drag and drop in the timeline, which is in the lower plane. Then you have to enter the values desired. 3. Play your timeline and be careful to check your remaining fuel and life. So here you have the fuel. It will constantly go down during the game, so you must be careful so you won't so you will have fuel to finish your timeline. You have also your HP. So when you hit obstacles, it will go down with the coefficient of impact. So each obstacle has a coefficient of impact that we call COE. And this COE is different for every obstacle. If the obstacle is in level 1, it will have a lower COE. If it's in the bigger levels, it will have a bigger coefficient of impact. And also here, catch stars to buy different upgrades in the store. I'm going to show you that later. Be careful because the obstacles, they make you lose life. And 6, land on the platform to complete the level of this. So here, it's the video. It's 2 minutes, but we can skip it. I'm just going to show you in level 1.
So this is the platform?
Yeah, the platform. So start. Okay, so for the first level, I'm just going to do the answer so you can see what it looks like. And in level 2, I'm going to show you the different way to crash and how you can play with it. So here you can drag and drop your blocks of code. And as you can see, we will catch all the stars so you can we can buy the upgrades in the store afterwards. So here, and when your timeline is too long, you have another page so you can really put the amount of blocks of code you want. I'm going to show you 4 levels. Because we cannot show you all the 18 levels. We have 6 different planets with 18 levels. So it's kind of, would be long to show you all the levels. And it goes with difficulty. So first level, it's really easy. You can do it really easily without much fuel. And the last levels, you really have to buy the upgrades or else it's really difficult to do the levels. Okay, so we can play it.
So
is there any sound?
Well, no, there's a music still.
Oh, just music.
Yeah, and then so the rocket it executes like every block you put in the timeline sequentially and stores everything into a list of instructions and then it executes it. So here we have a pre-planned perfect run, so we get all 3 stars, which you can see over here. By the way, the gravity is included on the top.
Yeah, right.
And it changes for.
So you have the level and the gravity for each planet and level. So you can adjust your acceleration because it will impact the wait time and the acceleration. So you must gauge and see what the difference is between the planets. So now you can go to the selection menu. You can here quit. So if you quit, you go to the selection menu. And here, as you can see, you have level 2 and level 1 that you can do, but all the others are blocked, so you really have to do them in order. So here, if we do level 2, we can show you the ways to crash. So the first way to crash is you run out of instructions to do. So if you don't complete your timeline, like here, you just put an acceleration, and if we play it, so the timeline is going to finish, but you didn't land on the platform. So here you always have the reason why you crashed or why you didn't win. So here the timeline didn't finish. Then you have, if you don't have life anymore, so I'm going to show you the collision, if Mark wants to talk about how we did the collision.
Yeah, so for the collisions part, we did it all ourselves. So no library or anything. So it was really complicated because we tried to get the bouncing parent, but what happens is that when you rotate your object, the bounds don't rotate, so they just get bigger to go around your object and creates an even bigger rectangle, so the collisions are not accurate. So therefore, what I did is get the coordinates of the 4 corners of the rocket, for example, and then I cannot rotate it now because it always rotates relative to the upper left corner. So the 0. And then I had to put the 4 corners parameters relative to the center here, and then rotate, and then make them back relative to the rocket. And now I can compare the 4 corners to the either the four corners of the stars, four corners of the platform, or any other obstacles.
So here, as you can see, we have a little animation when it crashes. So here you have no more life since you crashed into first the mountain and then you crashed into the building. So you die. It's really hard to finish and land on the platform if you crash, since your timeline is supposed to do to land on the platform, and when you crash into an obstacle, like the default spinning, if you want, will bring you elsewhere. So your timeline afterwards is going to continue where you were at, and it's difficult to land because it's going to go off course. So we can afterwards show you the out of bound. The out of bound is simple. If you just go too far and too fast, you're going to hit our bounds. And we have the platform. So the platform is the same thing with the boundaries. So if you crashed into if you touch the platform, but you don't land on it, so by the sides or under it or even on top of it, you can die because you didn't land properly. So here's an example. And the last one is with the fuel. Okay, and the last one I'm going to show you in the level 7 because it's the fuel. So if you don't have fuel, you're just going to die. So here I'm just going to show you, go back. I'm just going to show you with the load game what it looks like. So load game, here is Jimmy. And here, as you can see, he's at he completed level 12, so level 13 is accessible. So you can click on number 7. I'm just going to show you what is number 7. So here 7. So here we must be careful. As you can see, the gravity is really low, so it will be difficult since the gravity of level 1 of the first planet was 30, if I'm not mistaken. Yes, it was. So now it's 7.15. So here, as you can see, we have different backgrounds and different obstacles for each planet. So here it's the little spaceship with the rocks. This, I think it's Mars, if I'm not mistaken. So we have different backgrounds. So as you can see, it's really, I don't know if you paid attention to the numbers, but as you can see, they're really precise. So the acceleration is 200 and for a duration of 1.5. So it's really easy to do as many solution possible because you can really go wherever you want and put a different acceleration, but for more amount, more lasting. So here we're gonna get all the. So here something went wrong, so it's crashing, and then it's continuing, so the timeline, and then it's going to crash.
I'm just going to head on level 13.
Sorry about that, guys.
Oh, voilà, I missed it so bad.
Okay, sorry, you put the instruction from level 13. It's for
Alright, so for the parts, for the error parts, we had many errors, like probably most of you had. So first of all, like I told you, we had the collision errors. So we had to find many ways. So we thought about using library, but I thought that it would take more time to get used to a new library than to just create our own ways of collision. So we created our own coordinate system. Also, we had many unknown bugs that we didn't know where they came from because we had so many objects inside of other objects. So it was really nested deep. So, for example, for only this level, we have game UI class. Then inside of it we have the timing class. Then inside that we have orders. Then we have the orders list class. And then inside we have level. And inside of that we have our objects. So we had a lot of classes, like 25, but most of them are one inside another. So it was complicated to debug. Also, other errors we had. I'll talk to you later.
Okay, so as you can see here, you are out of fuel. So that's the example that you can go to the shop. So here you have normal fuel. So here you can do the level selection and go into the shop. So here the shop, as you can see for Jimmy, he has already bought an upgrade. So he's already with a fuel of 125. So he can buy another one. And here you can buy also the life. You cannot buy the upgrades. You cannot buy the upgrades. You cannot buy the second before the first. So you must buy them in order. And if you don't have enough stars, it's also gonna tell you down here. So here you go. So I'm just gonna show you the last level, 13.
That's what we're gonna show. There's 18 levels.
Yeah, there's 18 levels, but we wanted to show you the most representative of our game. So here, that's a harder level because here, as you can see, it's really difficult to have the right angle to pass over the rock and then turn and land on the platforms. You have 20% angle. So here, yeah,
plus or minus 20 degrees. So for example, when you're completely vertical, it's 0 degrees, and then you can go between minus 20 or 20. But if you're at 21 degrees, then you will be considered to have crashed into the platform.
Yeah, so it's difficult, but it's possible, and you just have to play with the acceleration, the rotation, and really here I would say it's really the angles that are difficult to have. No.
Here we go.
So here we're gonna get the 2 stars, and then wait and change your angle to get the other star. And then I'm gonna go to the right corner to get the right angle so I can go and land on the platform. So as you can see, that's what it is. And I think it's about it. Yeah. So we're gonna continue.
So to continue with our poems, I personally made a really beginner mistake at the beginning of the coding process. So I put many things static that I shouldn't have put static. So it created errors because some non-static methods called other static methods, and of course that don't work. So we had to try it again, remove some static parts, and everything crashed, and try again until we have it right. So the only real static parts is the user, because once you selected the user, it stays the same with all the levels, of course. So you have always the same number of stars, and your life and all the fuel. Also, another problem is we used a sketchy method to merge our codes and upload it in the GitHub. So Chanton will talk to you about that later. But sometimes, for example, someone just uploaded his part of the same class, maybe like 2 minutes ago, and we didn't know. So we uploaded our part of the same class and we overwrite everything. But we didn't know, so we had to go into the versions, check what happened, what he had changed before, and that was also a problem. After that, we had an error with GitHub. We still don't know what happened. We call it the GitHub mystery, but sometimes when we uploaded, some weird strings or letters just appeared in the code, like randomly, and then it made crash everything, or sometimes some parts were missing. But it's not our fault because we copied and pasted like exactly everything. So it was a weird part when uploading it.
Okay, so what we learned from that project? We learned the importance of sharing code. We thought it would be like, easy teamwork where when you do a PowerPoint, for example, everybody uploads their part and it's not complicated. But sometimes we would come to the class and spend like the first hour and a half only like getting the right version, everything, all of our parts to work. So that was a big part that we underestimated. Also, we chose JavaFX at the beginning it is a choice that maybe we wouldn't make again because JavaFX is okay, and the reason we chose it is because we already knew what it was and we didn't have to learn anything else. But thinking back, we maybe would have chosen something easier, maybe for animations and collisions, and we would have took the time to learn it instead of losing time with JavaFX. Same goes for GitHub. So we didn't use GitHub in the proper way. Like at the beginning, we would only use it as the server to import and leave our code there. But if we would have learned how GitHub works before, maybe we would have lost less time. And also progressive debugging. I don't know if that's a thing, but sometimes we would code, and then we would go back and try to fix a mistake that we've encountered. And then since we didn't test our previous code in all the ways or many ways, it would be hard to backtrack and find the single mistake we had. So maybe you notice in NetBeans we have many system out prints with values and things. That was all for debugging, and we would have tested every single method first before having to go through that process.
Alright, now here are some reasons why we have the best project. Sorry guys. So first of all, our game is really focused towards learning some new stuff. So like Sandrine said, you can learn programming thinking because you have to go step by step in order to achieve a goal. You can't go from A to Z without going from each part. That's why we all know that's how we program, because you can just come up with a new game without doing anything. We have really to do each line of code individually. Now also you can learn the basics of forces, gravity, and physics, because you have to put in a force to go against the gravity, so accelerate, but not too much because you will crash, of course. And also that it teaches you problem solving and planning, because you have to think before pressing the play button. So you have to think, okay, I need to accelerate this much, then I have to rotate, then I have to wait, and I have to accelerate again. So your personal goal is to achieve the one level in a single time, so not to try it 3-5 times, but of course you will fail. Like we did 10 times before getting the answers for a level. After that, it teaches you money earning management, because you have to catch the stars and act like a currency, like a money. So you have after that to choose if do I really need some fuel or do I really need some life? Because if you have no fuel, but then you won't go really far because you will have no time to catch all the stars. But if you have no life, you can go really far, but if you crash once, it's over. So you really have to manage what you really need for the next level. Yeah, so it teaches you perseverance and patience, like I said, because you will fail many times and you have to wait, try again and again. And finally, it's a really creative game because there is 1,000 ways to do it. You can either start going left or going right, or start by accelerating. So it's there's infinitely ways, because you can start going for a star, or it's up to you to choose.
Great. Any questions?
Yeah, we have questions.
Did you ever manage to land after crashing?
No.
Well, it's actually we could have seen it as an achievement, a crash and then learn, but it's really hard to anticipate the crash. But so no, we actually never made it.
It can happen.
Okay.
What happens if you move something while the
script is
while it's playing?
Oh, it's just gonna store it for the next. Once you click the play, it takes what you have. And
Okay,
if you change it afterwards. It's just gonna be for the next one.
The button is locked, so you can't press it once the game has started.
Yeah, you cannot stop your timeline. So if you play it, the timeline is going to run till the end.
Okay.
Yes.
We can have negative acceleration.
Yeah.
So you can go backwards.
Yeah. So you will go even faster than what the gravity is.
I was just wondering, the picture, the background picture that you have for your menus and stuff, did you guys make that?
We actually used a pre-made image and then we modified it.
Okay, because it looks really clean.
Yeah, no,
You guys are good.
It's a good design, but it is a basic picture, but we changed it.
say if you rotate perfectly horizontal and then you accelerate horizontally, do you accelerate towards the bottom
Yeah,
as well?
exactly.
Alright, nice, I didn't see it.
Yeah, the one that I did in level 13, when I accelerated at like a little bit towards the top, so you won't go down. But if you really accelerate horizontally, you're really going to go down since the gravity effects. Yeah.
Thank you.
Okay, so hello everybody. Today, my teammates and I are going to present our projects that we've been working on since the beginning of the semester. And our project is called Shine. So basically, Shine is a 2D puzzle game in which it involves optic physics inside our game. So the motivation behind this is that we wanted to be a learning process for the players, and we want them to learn about optic physics as long as they play the game. And so we want to make our game fun, but also challenging. So no matter your level of knowledge in physics, you can play the game and have fun with it. And we wanted to make it as user-friendly as possible, so we want to make our game simple. So now I'm going to run through the game with you guys. So as you open the application, you see the main menu, and in that main menu you see our big logo in the center, and beneath that there's two buttons, the play button and the option button. So let's say, for example, you click on option button, you can adjust the sound of the music. And basically the music is just to put you in the mood in the game. If it annoys you, you can mute it. And so on the top left corner, you can go back to the main menu, and then you can click on play. When you click on play, it will lead you to the level selection menu, in which there are 15 of our level that we created. And since the theme of our game is sort of metallic theme, so we want to include metals. So easy is bronze, then silver is medium, and gold are harder levels. And now the player can freely choose which level they want to play. So let's say a player is more comfortable with optic physics and knows how the game works, they can play the harder ones. If they don't know anything about optic physics, so they can play the easier ones. So let's say, for example, they click on level 1. Then a box will pop up, and in that box, it's basically a tutorial on how to play the game. So it says, "Welcome to Shine. The goal of this game is to reach the endpoint, the red dot, with the light. To do so, you may rotate mirrors. Click outside the box to play." So when you click outside the box, a level looks like this. So the goal of this game is to get this red laser to touch the point. And to do so, you need to click on the mirrors to rotate it. So every time you click on the mirror, it will rotate by a certain angle counterclockwise. So let's say, for example, you click, and then you finish the level. Basically, another box will pop up, and it basically congratulates you and tells you the score. And the score is calculated by the time that took you to complete the level. So now you're here, you can go to the next level by clicking on this, or click outside the box to look at the level. And you can now analyze how object works and how like mirrors deviates the light. So on the top left corner, you can click to go to the next level. And now I'll explain to you what's inside this red rectangle. So you got the time in the center in seconds, and on the top right corner, you can click on it and go back to level selection, which will pause the time, and you can go back to your game and continue to play. So now there's a feature we did, is that every time there's a new a new, let's say, new object in this game, there's a box that's gonna pop up and it will explain you how the object works. So that's basically our game. Now the objects, we have the laser that is represented by this black rectangle with the red laser coming through. We have the mirrors, that is this, and the endpoint. We also have walls, which is this red brick, I guess. We have convex lenses, which is represented by this blue line. Oh, it's mirror, sorry. And we got concave mirrors. And finally, we have lenses. We also have a feature that the lens act with total internal refraction, I think. It's when it bounces back inside the lens. So yeah, that's basically it. That's the basic component of our game.
Alright, so for design we're going to start right into the media part, so simulating the light. I didn't use any libraries for this, I just did it from scratch. So first of all, I just break the problem into components. So the light is first emitted and then it travels somehow. And I have to check if it is something. If it doesn't, it just continues. If it's a wall, then it gets absorbed, and if it doesn't hit anything, if it is something that isn't a wall, it gets transformed and it continues to travel. So that's basically the life cycle. One way you can think of doing it is just to have it check, you calculate the path and then you check if something is in its way and what it should do then. But there are problems with that. First of all, I'm going to present this algorithm like that. It gets really complex whenever you have many objects on screen because you have to clear everything. So that's not really suitable. Also, it's not really clear how you would check that in a way that would make sense in the algorithm. And once you do, then you have to find out a bunch of information about the light. So where it's come from at its angle. So I guess it's not really practical or good as an algorithm. And there's also a huge fundamental problem to deal with, which is, do you write your algorithm so that it treats light as in continuous quantity or something discrete? The thing with classical physics treats light as completely continuous. You can have it's a spectrum with every possible value in between. But if you try to simulate it on a computer, then it gets really complicated. The values, on a computer you can never have really continuous things, it's a finite simulation. So you have to find paths to do it. And that makes that the algorithm I would create if I use this approach would be kind of unpredictable. Because many things could change it, and also I would have to create. There's not really any standard way to approach a problem then. If I make the process discrete, then it's much easier to compute. I can make it linear instead of and but there's a slight problem is that it might produce variant results sometimes depending on if I use which one it is. So since making it continuous is practically impossible, I just stray away from this whole mode of thinking and just try to simulate it using something very ambiguous. Alright. So, okay, so I was kind of inspired. I read a bit about quantum physics for fun, and what struck me is that light light has a quantum state, and it gets affected by unitary transformation, which are basically a rotation of the amplitudes. So here what I thought is, if I have a map of everything of the level and put transformations in it, I could just verify if there's one transformation here and apply it to my light, which is a vector. So that's a very fast way, and it would be kind of easy to implement any kinds of thing in the system. So it's like a matrix. All right. So that's what it says. So that's the algorithm I came up with. It's more fleshed out. So that's basically how the light works in the levels. You have the light that's emitted, you create a new array, and it traverses the array in different ways depending on which reason. So if it's on path, it checks if it's the identities, so if the light doesn't change, it doesn't do anything, it just continues. And if it's a zero transformation, then it gets absorbed in a wall or something. And if it isn't, then it just applies the transformation, creates a new array, and it continues.
Okay, so I'm going to talk about the general design of our project. First of all, our project is a glue-on project, which is known for its compatibility with iOS, Android, and PC. We didn't have the time to adapt it to both Android and iOS because we were missing hitboxes, which were too small for fingers to touch, and we would have had to change some events like an on-mouse click for our mirrors. But otherwise it would have been completely adaptable to Android and iOS. So the way glue-on works, it's made with views and layers. Every view is like, for example, every level was a view, the menu was a view, every different screen that you see is a different view. So we made two types of views. We made the level, which extended view, and menu that extended view. And we made a general level with the time at the top, the level number, and then we extended every other level from that. The layers were the things that would pop up in front of the screen. For example, when you would win, you would have the winning layer, and when you would see new attempts, you would see the tutorial layers. That's basically it. Okay, so every other element, every mirror, lenses, walls, light source would extend element, which had implemented the mappable interface. The mappable interface was to make sure that it could be mapped, and therefore the light could see if it came in contact with it. Every element would have a draw method, which would be what would happen on the screen, what would everybody see, and behind the backend, what the light would find when they came into that place. So the biggest part of our project were the mirrors. We had the plane mirrors, which were either orientable, which meant you can click on it for it to move. Every time you clicked on it, the angle would be modified by 1 over p, 1 over 20 of p, pi, sorry. We had a speed limit, so you couldn't even spam the click because it would create an overflow and the application would crash. Otherwise, we had the convex mirrors and the concave mirrors, which were not orientable because it would have caused too many problems. And those were drawn with arcs of circles. For the lenses, we only had time to implement convex lenses, which were made with 2 circles, and whatever would be in the union of these circles would become the lens. We were able to apply total internal refraction, as you saw before. And the transformation would be modified when it would reach one of the edges of the lenses. And depending on the angle of incidence, it would either reflect or the angle would be modified. So to conclude, we would have liked to add concave lenses, diffuse light, which was one of the main things we would have loved to have in our project, but it became we didn't have the time, even though algorithm for the light that we came up with would have been able to do that. And we would have liked to transform it into iOS Android, but we did not have the time to do so. But otherwise, our project was a success. Our light is a very good simulation of the light in real life, and we're happy about that. Thank you.
Question? No question. Okay, thank you.
As you might all remember, our app is called Trivial. It is a multiple choice quiz desktop application with educational purposes. The topics vary from mathematics, elementary science to general knowledge. Now, said like that, it might seem boring to you all, but please bear with me, since this application is made to increase competitiveness between the players by making them collect points, by answering the most questions in the least amount of time at the same time as seeing the progression of the other players live. You'll see when playing later, the tension will be palpable. So as exciting it is for the players, we believe it is an even greater experience for the teachers of this world. In fact, every teacher wishes to transform their sometimes boring classes into an interactive session where the students actually are interested and motivated to learn. I'm sure you've never seen a 10-year-old actually having fun at school, but this was the past. So why should all the teachers actually use our application in their classes? Simple. We believe its simplistic design removes all useless distractions from students, letting them concentrate even more on their task and perhaps even make them learn better. Also, our app is made with you in mind to make everyday people use this app in a seamless way. Now, let us show you what it looks like.
Okay, so before I present the menu and the view and all of this, I suggest you open some computers. So like everyone has a computer open. And we suggest you use the computer of the school because we know for a fact it works. But if you use your own
Go ahead, open your computers. You're gonna have a quiz and math.
If you use your own computer, you need one of the latest GRE Java. For a menu, gotta wait a little.
Yeah, wait a minute for them to log in. Chris, you wanna do your math quiz?
So while you're logging in,
Yeah.
it takes like 100 years.
No, not anymore.
Oh, okay.
You want a computer? Let's play over it.
Okay, so I'm gonna explain the menu now. So we have the main menu, which has the host game option, the join game, and the options. Okay, so for the options, we put a slider for the sound. We set it at 0 for the presentation because we want it to be a little obnoxious. And we have the resolution, which you have like full size, which is a factor of 1 and 3/4, 2/3, or I think I don't remember the last one, but it doesn't matter. Okay, so then you can confirm and it will come through the options. So now, if you host the game, you need first to enter a name and then click on host. And then you will get assigned an IP and a port, which you'll share with all of the players. And then the other one is joining, which is a similar principle. You put a name, you join, and then you get the IP from the hosting player and the port, and then you join the game and wait for the host to start the game. This is the game interface. You'll have the question, which is shown. Then you have your grade here, which shows which grade you're in. The score you're presently in, you're aiming for 1,000, and the first place, the person that is currently in first place. And then you have all of the multiple choices. And then at the end of the game, you'll have a leaderboard, which shows the top 3, and then you'll have the rest of the players in the second leaderboard.
So who's gonna win?
Me.
Okay, we'll see. We'll see.
So how does this work? So first, when you enter the IP, from the host, you get connected to the socket of the host. So if you, yeah. So the host receives all the data from all the other players. So it receives the object of a player, which has the score, the name, and everything you need to be able to place him on the bar, the progress bar. So when he receives the data from the client, after that he sends them up to all the other clients so that everyone is connected at the same. The only problem with that is that since the host receives a lot of data at the same time, sometimes it can get laggy for the host. Yeah. So when you connect with the IP and everything, you get this, which lets you in a waiting state so that when you receive the signal to start the game, everyone starts at the same time. And then when the game starts, it sends the signal to everyone, and the game interface is created, which creates all the questions.
So how the questions are created, we have two different methods. The first one is to create arithmetic and fraction questions using an algorithm. So this algorithm also included creating false answers to give you 3 choices plus the correct answer. So what was the most complicated here was to make sure that the false answers created by the algorithm were actually plausible, because otherwise it would just be too easy to see what is the right answer. Also, avoiding that, avoiding divisions by 0 was a big part because in the fractions. And so also, in order to prevent the users to be able to just spam the same button to have their same answer each time, we shuffled the order in which the good answer appears, so it won't be always in the same box. And so otherwise, the questions that we pre-made are all the questions concerning like general knowledge, science, and logic, because it cannot be generated with an algorithm. Well, not at our level. So we use resources like La Classe de 5e, it's a game, or also Allo Prof, to inspire ourselves and follow the curriculum of elementary school. So this is it's important. It's going to probably be easy for you guys, but we aim this game for elementary students.
So when you get to the game interface, so you get all the questions that are shuffled, and you have your progression bar. So every time you click on the question, you send the data to the host if you're not the host, and then send it to the clients. And then they will receive your score and will update automatically the bar. When you are in 6th grade, the way it works is that when you answer a question correctly, you increase in grade until you're grade 6. The grade 6 is the hardest questions, which are kind of really hard. And then if you miss one, you go back to grade 1. The skip button is to prevent from going down. So if you don't know the answer, you can click the skip button, but you get a time penalty. So if you are in grade 1, let's say, if you click the skip button, it won't really be helpful for you. But if you're in grade 6, since you get more points when you answer grade 6 questions, it makes more sense to skip the question if you don't know it. So if you're in grade 6 and you're speaking all the questions, you get a star. So this shows that you're getting the most amount of points and that you're going to end fast. And the first person has a crown to signify that he's the top person. Also, the progress bar fills with your color, so you know which one you are, since the other person will be dots. And that's pretty much it for this one. So when you get to the end game and you get your leaderboard, as Guillaume said, you can export as a text file to get all the data from all the users in the game. And then you'll be able to, let's say if you're the teacher, you can see who did the best. So now we can test the game.
So I think I see a lot of screen with the game already. So
I haven't seen anyone in this table. Where's the game?
I sent a Mayo to everyone with an archive.
Non, mais parce que c'est
I was able to download it because it says a text file, so I cannot.
No, you have to really like open and like right click, go to an unzipping program like WinRAR.
Let's give them a few more minutes. Let's see who is gonna get the free lunch.
You're funding it?
Guillaume is gonna fund it.
So please don't start a game. I'm gonna be the host, so you all connect to me. Because and please make me sound
I'm getting there. Right.
Pour le mettre les deux sur la même écran, à place d'être extended.
No John. So why everyone is on the front? What happened?
They want to have this screener or extended or vice versa, so we're helping them with that.
disconnect my computer so they don't see my answers.
Yeah, okay.
Okay.
Okay, so we're gonna.
Well, I'm just gonna record it because otherwise I
Okay, I'll actually buy poutine to the winner.
Oh shit!
Yeah, I said you win, you're gonna get a free lunch.
For real?
Yeah, for real. Guillaume is gonna give you free lunch.
Guillaume's give the free lunch?
Okay, are you ready?
Nope, we haven't also joining.
Last person. And then we start.
Yeah.
Okay.
Where's my mouse? Let me just find. Okay.
Okay, let's go.
Let's see if it works.
It works. I didn't change my resolution.
Yo, it's not working.
Did you change? Oh yes, you have to change your resolution if your computer is.
des modes. Je connais pas les modes.
C'est trop de. I'm gonna look on my computer.
Moitié des gens quartiers qui
Des questions sur la phase de
Oh my god, you.
C'est moi qui en first place.
C'est Miss Friday, it's Mario.
C'est moi en first place, bro, mon
C'est moi, poulet!
Ils sont passés.
Avec 42.5.
Moi je fais ça plus
Je suis pas en premier.
Ouais, toi t'es tout seul là. Hey, je suis tout seul dans mon jeu, j'ai le coup de monde.
Ouais, moi il y a un problème.
Moi le Wi-Fi il a lagué.
Moi il n'y a plus de questions.
That's too many Oh ouais, c'est comme
Je suis seul, ils sont bien à l'us.
Oh, les autres sont arrivés! Les autres sont arrivés!
I think Felix is winning, huh?
overestimated. We overestimated the Wi-Fi because my computer just froze because there's too much information coming in.
C'est calme.
Il y a plein d'excès. C'est quoi cette question-là? C'est vrai? Je savais pas. Tous les insectes ont 6 legs. I didn't know that. Je savais pas. Les araignées, c'est pas des insectes, c'est des araignées.
Okay?
So
So, who is the leader?
Thierry. C'est moi, poulet.
Terry. Terry is the one who's gonna get the lunch.
The leading board is yeah, some people have like different. I think he kind of lost the connection. So. I remember his. Wow. Okay, so if anyone has a higher score than 865,
I got 1,000, bro. I don't know about this. Ouais, c'est ça, Munger dans son écran, il a gagné.
So, do you guys have any question? That, oh, you want a question not related to the prize, but to their project. So thank you, that was really good.